So we look at section 5.6 on complex numbers. We want to start up with a little bit of a warm-up, and we're going to talk about simplifying radicals, first of all, just in review. And so we have to remember when we're simplifying a radical, we are going to take and write the radical as a perfect square times what is left over. So that perfect square times the leftover is going to give us the ability to simplify radicals. So in this case, I would take this 12 and break it down into the square root of 4 and the square root of 3, which gives us 2 root 3. I can say this 2 radical 3. I can say this 2 root 3. Any one of those is fine. Square root of 45, I'm going to break that down into the square root of 9 and the square root of 5, which is 3 radical 5. The square root of 50, I'm going to break that down into a perfect square, 25 times 2, which is 5 radical 2. Now the square root of negative 4, I'm going to break that down into 4 times negative 1. 4 is a perfect square, and the 4 becomes a 2 times negative 1. So now the question becomes, now what do we do with the square root of negative 1? And that really is the question that we're going to be focused on today. And that question comes to the root of the idea of an imaginary number. And an imaginary number is something that we use. As we were saying, an imaginary number is something that's defined as a number whose square is negative 1. So in this case, this square of negative 1 is going to be called a number I. And that number I is written cursively with a little curly part at the bottom, and it's a cursive I. It's very similar to the number pi. You're not freaked out by the number pi. Don't be freaked out by the number I. And the number I equals the square root of negative 1. So as we simplify this as an example, we take the square root of negative 18 here. We would rewrite that as the square root of negative 1 times 18. And then the square root of negative 1 becomes I. The 18 breaks down into 9 and 2. The 9 square root becomes a 3. And then we write it as 3i radical 2. We want to make sure that we're writing our numbers as an a number times I times the square root of a number. And we want to avoid writing this as 3 radical 2i because the tendency is to have that square root symbol go over the radical. So we do not want to do that. We want to instead write it as we did over here. So let's look at some practice problems here where we're simplifying the numbers. So the square root of negative 4 is going to be the square root of negative 1 times the square root of 4. So that's I times 2, and our answer is 2i. Now, just a reminder to write your cursive I as your imaginary number. Don't write it as a block I or anything like that, but that's written as a cursive I. Okay, let's look at our next one. Square root of negative 20 is the square root of negative 1 times 20. So that comes out as I. Perfect square that goes into 20 is a 4. So that's I times 2 times the square root of 5, and written in the correct order, 2i square roots of 5. Square root of negative 7, that's the square root of negative 1 times the square root of 7. So that's I times the square root of 7. And because this cannot go any further, this is our answer. So square root of 7 doesn't have a perfect square that goes into it. Let's look over at the 27. The square root of negative 1 times the square root of 27. Can you think of a perfect square that goes into 27? Hopefully you did. 9 and 3. So I times 3 times the square root of 3. So the correct writing of my answer would be 3i radical 3. Now, let's take this idea of complex numbers and let's expand what we know as before. These complex numbers are going to be written in the form a plus b times I. And a complex number is merely a real part of a number and an imaginary part. So I want to show you then how to write these next couple examples as complex numbers. So in example 3, we have 4 plus the negative sign. I'm going to write it first like so, But hopefully you start to see that a negative sign inside a radical comes out as an I, just like there. So here on the second one, negative 6 plus I root 24. Now let's break down the 24. Square root of 4, square root of 6. Square root of 4 comes out as a 2. Now we have 2I radical 6. One item of note, you do not combine the 6 negative and the 2I because they're not like terms. Let's look at our next one. The negative on the negative 8 comes out as an I, and the 8 is going to be left inside. 8 breaks down into 4 and 2, and so the square root of 4 becomes 2I radical 2 plus 3. Hopefully you see on that one, I brought the 2 out front immediately and put the I at the back. Now example 4 is an area that I really want to focus on, and what I'm going to have you do is put a big bubble around this. So go to your insert, go to your shapes, go to your cloud, and I want to choose a bubble, and I'm going to choose it in red because I really want to make sure that we emphasize this idea of what we're about to do here. This is an idea, and in the past we've had a real big problem with in terms of doing this correctly. All our focus on is combining like terms. So I'm going to underline my like terms. 4 and negative 6 gets me negative 2. My other like terms are my i's. So in this case I have 3i minus 4i, so that's negative 1i. So if I'm writing my final answer, I'm going to say negative 2 minus I. It's important that we combine our like terms. Let's look at the next one. But before we look at the next one, we need to notice that there's a minus sign in between there. And I'm going to highlight that minus sign because it is critical that we take that minus sign and we distribute it to both parts at the back. So first I'm going to distribute negative 3 minus 2i plus 5 plus I. Now let's underline our like terms. First of all, our real numbers. Negative 3 and 5 gets us 2. Secondly, our i's. Negative 2i and positive 1i gets us minus I. So my answer is 2 minus I. I can't emphasize the importance enough of the importance right here of distributing to both parts. This is a thing that in the past we have had tremendous issues with students forgetting to distribute to both parts with there's just that minus sign. Some people benefit from thinking of that not just as a minus, but actually a minus 1 to distribute, and sometimes that helps people to remember that. So I hope that'll be helpful in you remembering that process. Let's look at our next page. I made a little chart for us, and up until now, what you have known as all the numbers that exist have been these real numbers. And these real numbers, up until now, existed with natural numbers, whole numbers, integers, rationals, which include fractions, and radicals as well, which make up your irrationals. But now we've added in a second set to make up the complex numbers total. And the real numbers plus the imaginary number equals the complex. Now these diagrams are not drawn to size. The imaginary numbers are actually far bigger than the real numbers. And so I need you just to realize that that is not necessarily a scale drawing. As we move forward, we're going to start to talk now not about adding numbers that are complex, but instead by multiplying. So just as a reminder, as we look at our problems, we're going to be multiplying numbers. Let's think about some review here. If we have 4i times 5i, that's going to give us 20i squared. And up here, we notice that I squared equals negative 1. So that's 20 times negative 1, which is negative 20. So anytime you see I squared, realize that it equals negative 1. All right, let's take this next one and FOIL it. 3 times 5 is 15. Outside, 3 times negative I is negative 3i. Inside, negative 2i times 5 is negative 10i. And last, negative 2i times negative I is positive 2i squared. We're going to combine our like terms in the middle. That gets us negative 13i. Then on either end, we're going to have 15, and this plus 2i squared becomes a minus 2, because remember, I squared equals negative 1. So my final answer, 13 minus 13i. Okay, let's move over to our next one. Let's FOIL again. 4 times 7, 28. Outside, 4 times 2i is 8i. Inside, negative 5i times 7 is negative 35i. And then last, negative 5i times 2i is negative 10i squared. We combine our like terms like we did before. That's negative 27i. And then on the front and the back, we have a 28. And the minus 10i squared, because it's I squared, that's a negative 1, it's going to become plus 10, which gives me an answer of 38 minus 27i. Notice my I is written in cursive as we work through that. All right, let's move to our page 4. On this last page, our focus point is going to be solving an equation that may end up in complex solutions. In other words, we're going to have to use square roots possibly to do this, and often what we're going to see is this is going to happen when we have a quadratic term, in other words, the x squared term, but no linear term. So the problem's going to look like this, ax squared plus c, and I'm actually going to change that to a c there, just because in our normal equation, it's ax squared plus bx plus c. So we're going to change that so it's a little bit more. How do we do this? We isolate the squared term and then take the square to both sides. And remember, when you have two square roots, you get two answers, and that means your two answers have to have a plus or a minus. So here we go. Example 6. We're going to start by isolating the x squared by subtracting 49 from both sides. So I'm going to subtract 49. Next, I'm going to take the square to both sides. So I take the square root of x squared and the square root of negative 49. Okay? Remembering when you take the square to both sides that you have plus or minus. What is the square root of negative 49? Well, the square root of negative 49 is going to be 7. But the square root of the negative becomes 7i. So our answer is positive 7i or negative 7i. Let's look at our second one. First step again is isolate the square. So I'm going to subtract 4. Next, I'm going to divide by 2. Next, I'm going to take the square root of both sides, remembering your plus or minus. Next, I'm going to bring out the I and break down the 12 into a perfect square and what's left over. And next, I'm going to rewrite the square root of 4 as 2i radical 3. Our last one, we're going to subtract the 2. We're going to divide by 3. We're going to take the square root of both sides, remembering our plus or minus. We're going to bring out the I. I'm going to break up the fraction into 2 radicals. Now, my last step is I need to rationalize the denominator. I don't know if you remember this, but to rationalize the denominator, we have to multiply both top and bottom by what's missing to make that square root of 3 a perfect square. So in this case, what we're going to multiply by is the square root of 3 over the square root of 3. That's going to give us x equals plus or minus I square root of 6 all over the square root of 9, which is 3. So that gives us our final answer, a complex number for sure as we're working on this. I hope this has made sense as we work through our homework as 1 through 18 all and 32 through 45.